Let's continue our discussion about the medians of a triangle and that point, that special point where the medians of a triangle intersect. So first of all, let's review the definition of a median of a triangle. The median of a triangle is a segment that goes from a vertex of the triangle to the midpoint of the opposite side. That's what we call a median. That's the definition. So if I consider this triangle here, ABC, I have median CD. And CD is a median because it goes from vertex C to D, which is a midpoint of side AB. So I could actually denote that being a midpoint with some congruent segment notation. In like manner, I have median BF and if BF is a median, that says that F is the midpoint of segment AC, and I can denote that again with some congruent segment dashes. In like manner, the third median of this triangle is going to be AE. And again, that would tell me that E is the midpoint of CB, and I can denote those segments being congruent, CE congruent to EB with congruent segments, dashes. And so those are the three medians. And we found out recently that the intersection of the three medians, the intersection point of those three medians, is called this really interesting point, the centroid. And we discovered, in fact, we have a project about the centroid. The fact that the centroid is the center of gravity of the triangle. That's a very important aspect of the centroid. It is the center of gravity of the triangle. So this we talked about recently. The new topic about centroid, or new property of centroid, is that the centroid is 1/3 the distance from the midpoint to the vertex. So let's investigate what the world this statement means here, that the centroid is 1/3 the distance from the midpoint to the vertex. Well, if I consider this midpoint D, and this median DC here, what that is saying is that DG is 1/3 the distance of DC. So the centroid is 1/3 the distance from the midpoint to the vertex, 1/3 the distance. So it's really going to be handy if I take this and I divide this median into thirdsies. And I have it about right. So this guy, and this guy, let's label those with yellow. Those, let's label them with yellow. Those segments are all going to be congruent. I've split that median up into distance of 3. In like manner, I can do the same thing because the centroid is 1/3 the distance from the midpoint to the vertex. So if I talk about the vertex midpoint F, this property says that FG is 1/3 the distance of FB. And again, let's divide that guy into thirds, and we'll use a different color here. That would tell me that these three little segments are congruent there. Let's do those little thick segments, because this is 1/3, 2/3, 3/3. In like manner, EG is 1/3 EA. So EG is 1/3 EA, and we will divide that up into congruent segments. So I have 1, 2, 3 thirdsies. Each median is divided up into third. The centroid is 1/3 the distance from the midpoint. So let's use that property and answer some questions. Here is another picture of triangle ABC, a different arbitrary triangle ABC here. And I have the fact that FB is 3.6. FB is 3.6. So if FB is equal to 3.6, and from my previous discussion, I can divide that into thirds. I can find all of these other distances. I can find FG, and I can find GB. And we know by the segment addition postulate that FG plus GB must equal to FB. And FG is going to be 1/3 of 3.6. I believe 1/3 of 3.6 is 1.2. And since I have it divided into thirds, and GB is actually going to be 2/3 of 3.6, GB would be 2.4. Oh, right away, and then that's going to answer my first question. GB is going to be 2.4. The second question here is, what is AG? I want to find AG. Well, that's going to be easy to find AG because they've given me AG. AG is equal to 6 centimeters. That's not that interesting. But if AG is 6, let's go ahead and find the rest of lengths of parts of this median that we're going to call AE. And again, by the segment addition postulate, I know that AG, whatever that AG is, which is 6, AG plus GE, that's going to have to equal AE. And if I know AG is equal to 6, let's see, and that's going to be 2/3. Kind of divided, so therefore both of these little sections will be 3 here. Well, and then that rascal has to be 3. So therefore GE would be 3, and easy enough to see that AE is equal to 9. If you need to pause the video, go ahead. I'm going to erase these numbers and clean my diagram up a bit. And then the last statement I have is that DG is 2.8. DG is 2.8. Let's see here. DG is equal to 2.8. Well, if I follow my advice from before, DG is 2.8, that's going to be 1/3 of DC. This is going to be 2.8. Both of these other pieces will also be 2.8. And to find the measurement of DC, which is what I wanted down here, I'm simply going to take 2.8 and multiply it by 3. And therefore, DC is going to be 8.4. And keep in mind, our diagram may not be to scale, and that's okay. And therefore, DC is 8.4, and we can certainly find, if I need be, what this measurement of GC would be. GC looks like it's going to be twice 5.8, and I believe that's going to be 5.6. And again, I see that GC plus DG is going to equal DC by the segment addition postulate. So that's a nice little property of centroids, is that the centroid is 1/3 the distance of the median, 1/3 the distance from the midpoint to the vertex of the opposite side. Some nice little properties of the centroid. The centroid is an amazing point, the center of gravity, and it's going to split that median into thirds. So you have a very easy Google assignment that is associated with this video. Have a wonderful break. Thank you.